All right, this is lesson 5.5, and this is the last of the 3 videos on it, and maybe a little bit trickier, but not too bad as well. So hopefully those first 2 videos went smoothly, and then this will finish up 5.5, and this will finish up chapter 5. All right, so questions are going to look like this. We're on page 7 now in your note packet. Use identity to find all 6 trig functions for the given angle. What happens is they're going to give you the cosine of 2 theta, and they want, when they say theta here, they would like the sine of theta, they'd like the cosine of theta, they'd like the tangent of theta, and they like all the reciprocal functions too, the cosecant, the secant, and the cotangent. And so they're asking for quite a bit here, and it seems daunting at first, but it turns out it won't be too much work. So we've got the cosine of 2 theta. Let's look back at our double angle identities. We come back here, cosine of 2 theta. And if you remember, there's 3 identities for the cosine of 2 theta. You've got this one, and this one. And so which one do you choose? And the answer is, don't choose the first one because there's 2 variables over here. So don't choose that one. Choose the second one. That'll help you find the sine. Or choose the third one. That'll help you find the cosine. And in between those 2, I think we can come up with the other 4 trig functions. So let's use those 2. So let's use first the cosine of 2 theta is 1 minus 2 sine squared of theta. So let's come back there. We got the cosine of 2 theta is 1 minus 2 sine squared of theta. And this is just, hopefully as simple as it looks, it's just an algebra problem. I take out the cosine of 2 theta, and look, they tell me it's 3/4. So I put in 3/4. 1 minus 2 sine squared of theta. Not bad at all. How do I solve this for sine? Well, I'll take off 1 from both sides. So subtract 1, and 3/4 minus 1 is negative 1/4 equals negative 2 sine squared of theta. I'll scroll that up a little bit for us. And then I'll divide by negative 2. Negative 1/4 divided by negative 2. That would give 1/8 equals the sine squared of theta. How to get rid of a square? You take the square root. The square root of 1 is 1. And the bottom I've got the square root of 8. And you know the square root of 8 would simplify because 8 is 4 times 2. Square root of 4 is 2. So I get 2 root 2. Then you know you can't leave square roots on the bottom. So multiply top and bottom by square root of 2. And after all is said and done, you get a square root of 2. And here, these 2 square roots, square root of 2 times square root of 2 gives you 2, times the other 2 gives you a 4. And hopefully as I was doing that, you're thinking, wait, he took a square root. Is that plus or minus? Well, let's see. They tell us theta is in quadrant 3, a smart trig. That is minus. So after all is said and done, I've got the sine of theta is negative square root of 2 all over 4. All right, not bad. Let's try it again. And again, in the homework, there's not a lot of these. There's maybe 1 or 2 of these. Let's get the cosine of theta. So come back, look at those identities one more time. And instead of that second identity, let's use the third identity. So the cosine of 2 theta is 2 cosine squared minus 1. So cosine of 2 theta is 2 cosine squared minus 1. Cosine of 2 theta, look, it's still 3/4. No big change there. 2 cosine squared of theta minus 1. Let's do our algebra. We'll add on 1 to both sides this time, so I get 1 and 3/4, otherwise known as 7/4, equals 2 cosine squared of theta. Divide by 2. 7/8 equals the cosine squared of theta. Take the square root. Don't know the square root of 7. I know the square root of 8. We just did it. It was 2 root 2 equals the cosine of theta. I know I'm in quadrant 3, so it's negative. I know I can't leave a square root on the bottom, so I'll multiply top and bottom by square root of 2. I get negative square root of 14 all over 4 is the cosine of theta. And you might be thinking, wow, we've got 2 done. We have 4 more to go. This is a lot of work. But it's not too much more work because I've got the sine, I've got the cosine. How to get the tangent? Remember tangent? Tangent is just sine divided by cosine. So there's my sine. You have square root of 2 over 4. My cosine, so divided by negative square root of 14 over 4. And do you remember how you divide? You multiply by the reciprocal. So the top fraction I leave. The bottom fraction I take the reciprocal. The 4's cancel out. The negatives cancel out. I get square root of 2 over square root of 14. You rationalize that. So take top and bottom by square root of 14. Square root of 14. And I'll get 14 on the bottom. I get square root of 28 on the top. Wait a minute. 28 is 4 times 7. So I get 2 square root of 7 over 14. And the last thing I'll have to do is divide by 2. So I'm going to get the tangent is the square root of 7 all over 7. Now at this point you might be thinking, wait, you're still only halfway done, which is true. But the other 3 are not hard to come by. The other 3 are the reciprocals. So if I want the cosecant, I just come here and take the reciprocal of sine. If I want the secant, I come and take the reciprocal of cosine. And the cotangent, I take the reciprocal of tangent. So I'm going to leave that part out just to keep this manageable. But if I want the other 3, they're just the reciprocals. Reciprocal, you just flip it over. So the negatives will stay negatives. And if you have a square root on the bottom, of course, you'll rationalize it. All right, one last problem in the chapter. This is it. They're asking it backwards this time. It's a little trickier. This time they'd like the sine of 2 theta, and they give you the cosine. So it'd be a bit of work in here, but not too much. So you come back to your identities. What's the sine of 2 theta? Oh, look. Here it is. Sine of 2 theta is 2 sine of theta, cosine of theta. So I'll write that down. Sine of 2 theta is 2 sine of theta, cosine of theta. So I'll come over here. I'll just sub in. I'll go 2. Oh, shoot. They didn't tell me sine. They told me cosine. Negative 12/13. But they didn't give me sine. And hopefully as you're looking at this, it reminds you of those other problems we've done where you're missing things. How do you find the missing part of it? Go back to Pythagorean identity. You always know sine squared plus cosine squared equals 1. Cosine is 12/13 negative. I'll square that. So I'll just put it in here right now. Negative 12/13 squared. Over here I've got the sine squared equals 1. I'll square that out. I get 144 over 169 equals 1. This is sine squared. And I think you've done this problem enough. This comes up very frequently, doesn't it? I'll subtract. So 1 minus 144 over 169. You get a common denominator of 169. So 1 is really 169 over 169. 169 minus 144. How nice is that? 25 over 169. Take the square roots. The square root of 25 is 5. The square root of 169 is 13. I am in quadrant 3, so I know that's negative. So after a bit of work, I've got the sine is negative 5/13. Sub that in, and let's multiply. On the bottom, I have 1 times 13 times 13, 169. On the top, I've got 2 negatives, a positive. 2 times 5 is 10. 10 times 12 is 120. So I've used my double angle identity for sine of 2 theta to figure it out given the cosine. And that's the last part of this. So they're going to give you a single angle and ask for the double angle. They'll give you the double angle like the first one we did and ask for the single angle. And those will involve your double angle identities. And guys, that is it for chapter 5.